Are you surprised of this year's Nobel Prize?
Yes, the prize today in physics is about how large quantum system could behave quantum. And the prize today is to award the three people who work on this and showing the property of quantum mechanics is holds even for large systems. One of them is tunneling, and second one that also quantization, like the atoms are quantized, like a model board that we have different energy levels. That it was also an open question, or is also for our system, this quantization is holding, and this was been shown by the three laureates of today. Yes, and then of course these have many applications. What it was mentioned about quantum computers,
Yes.
quantum memories, and also what is very important to probe the frontier between the classical world and the quantum world.
Yeah.
Yes. Both
So what is the imagination of them? And
sorry.
so what are like
In
the
your
image of these professors and these laureates?
I mean, they are, of course, they deserve it because no one was believing that you could do quantum mechanics for large systems. It was questioned, and then, of course, these people show that it's possible. And that, I think, is a big merit, and that have been the work that people have used once it's done to show that it's possible to have quantum behavior, even for large system, that have really started all this qubit-based superconductor. That I think a pioneer work for data, building quantum computer based on the superconductor, it is challenging, and then there are many companies like Google, and IBM, and also in USTC in Shanghai, they're also doing that.
Yes,
there are many competition. There are very competitive work now between between different places in the world.
And then do you think that is related to the strong power of the supercomputer, that is like the conductor qubit show the stronger power than the others? Because also I asked a question about neutral
it's
atoms.
hard to answer which platform is the best.
Okay, so
There are many alternatives now.
Yes.
Superconductor is one, ion trap is one, neutral atoms, and also photonics.
or
Then there are four possibilities, and there are no one have all the requirement. Then people are thinking of combining these systems together because there are no system who can do everything. That's what the question is.
You have to obey the fidelity and also the extended.
Yes, there are some, because there are also problems scalability. How much you could have, like say superconductor, how many qubits you could have in the fridge. But are you talking about 1,000? Yes. But you're talking 1 million? It's difficult. Then the scalability is very important,
Yes.
Yes.
So,
and also the gate fidelities. And
So for example, the trapped ions have the best fidelity.
yes,
And
but have issue with the scalability.
And cold atoms have the good scalability.
Yes, exactly.
And not very good for the fidelity.
Yes.
And then for the superconducting qubit is that in the middle. And then, but for example, do you think that now this year 2025 gave a superconductor qubit, which means that for the neutral atoms, or for the trapped ions, there's less chance to get Nobel Prize for the future?
This we are not allowed to talk about the chance for the Nobel Prize for the future. Yes,
so we say how the origin or novelty for the superconducting, if you think it's a novelty, then now there's also exist for this superconducting qubit. But how to say the novelty for the other two or three candidates?
I mean, the other candidates are using like microscopic solution, like atom or ion, that we understand very well how the system works, right? But for qubit is have advantage is using microfabrication, what is like standard techniques, right? For me, like what they do in Shanghai, they try all the possible platforms, right? Then one idea that people could combine, maybe the ultimate goal in the future, combining all this together, and maybe adding AI machines adding classical computer. That I think the future. That you could have maybe hybrid system combining different platforms.
Yeah. So take iris stress
Yeah,
together
exactly.
and then
Yes,
put
yes.
a
And
strong.
adding AI machine and adding classical machine.
That's difficult.
That will be the future. Yes.
Now this year is also 100 years of quantum mechanics, and also
Yeah.
Nobel Prize gave this related to this quantum computer. Do you think that this is also a hint, or it will influence the future competition? That there is a more country or put more resources for
Of course,
building.
this is always the Nobel Prize when it's awarded on some topic is trigger a lot of effort
it's like a
worldwide.
trigger.
I'm hoping that
A
it will
strong
be more
trigger.
Yes,
interested in young people, right? Students, and then research and funding and so on for the
Yes,
future. We're
yes,
hoping that will enhance this
area,
effort,
yeah, yeah.
worldwide. Yes.
Yes.
Yeah.
And you have collaborations with China, I mean with Professor Pan's group, and China is eagering for a Nobel Prize of Physics.
Yeah, there is,
yes.
yes.
And in your opinion,
Yes,
as the
Marcus, when he asked me to where he want to go, and then he thought he want to go to the US, and after he said me, Papa, I want to go to work with Jean-Louis Pan, and then he.
That's your son.
Yeah, he started his PhD with Jean-Louis Pan.
Okay.
Yeah,
okay.
in Shanghai.
In Shanghai.
Yes, and working in similar things on superconductor.
And then for the for your specific topic is about
Me, I'm working in photonic systems.
So for photonic system also there's is a candidate for super.
Yes.
For quantum for quantum computer.
Yes.
So this, how do you think this is also so scalable and
photonic is if you think about it, this photonic is the only one who is scalable. Yes, because this is silicon electronics, silicon photonics, and silicon photonics is scalable. Because the processor of normal computer are having millions of gates. That's what people believe that super photonic is the only one what is scalable.
Okay.
Yeah.
okay,
Good.
that's all our question. Thank you so much,
Thank you.
Professor.
Okay, thank you very much. It was nice to see you. Yes.
Thank you very much.
Thank you. Bye bye.
Yeah.